14.3 notes, right triangles and trigonometric ratios. So we've been talking about sine, cosine, tangent, and their reciprocal functions, cosecant, secant, and cotangent. Go ahead and use those ideas to figure out what the sine theta of this triangle is, the cosine theta, and the tangent theta. And make sure you simplify those ratios. All right, so sine theta, when you're starting at theta, sine opposite over hypotenuse, 6 over 10 would simplify to be 3 over 5. Cosine ca, adjacent hypotenuse, 8/10, which should simplify to be 4/5. And tangent, toa, opposite over adjacent, 6/8, which simplifies to be 3/4. All right, let's look at the next one. For a standard position angle determined by the point 3, -4, what are the value of 6 trig functions? All right, so figure out where 3, -4 is. So we're going 3 to the right and down 4. We're on 1, 2, 3, and then down 4. Okay, so we're talking about that angle of your triangle. So then what you could do is connect it back to the origin and make a right triangle out of it. So then your sides are 3, and then since we went down, -4. And then the hypotenuse, we're going to use the Pythagorean theorem to figure out what the hypotenuse is. So we can call it C for a minute. So we're going to go a squared plus b squared equals c squared. Now, since your y there is a -4, but you're squaring it, it's always going to turn back to positive. So the hypotenuse will always be a positive number. Okay, so we get the square root of 25, which is 5. That's going to be that third side, the hypotenuse. So C is 5. Okay, now your theta is your reference angle. So when it says to find the 6 trig functions, if I want to find sine theta, cosine theta, tangent theta, cosecant, secant, and cotangent. So the sine of theta, sine, so opposite over hypotenuse. So we're going to say it's -4/5. And then the reciprocal cosecant would just be the opposite of that, -5/4. Okay, cosine theta, adjacent hypotenuse would be 3/5. Notice we don't need the negative for the cosine. And then secant, 5/3. Tangent, toa, opposite over adjacent, would be -4/3. Flip it for cotangent, -3/4. It doesn't matter where the negative goes. It can go on the top, on the bottom, out front, any of those spots. All right, so why don't you try number 2. This time your point is -10, -24. So find that hypotenuse and then find the 6 trig functions. All right, go ahead and pause the video while you work on these. All right, so if we do the Pythagorean theorem, you should have gotten the hypotenuse to be 26. Again, it's going to be positive because you're squaring both your negatives, which would be 100 and 576. So the square root of that, 676, is 26. So now if we want to find the sine of theta, opposite over hypotenuse, then simplify that. So 24/26, -24. But make sure you simplify that to be -12/13. So then the cosecant, just flip that upside down. -13/12. Cosine, ca, adjacent hypotenuse, 10/26, but simplify it to be -5/13. And then secant, flip that upside down. Finally, tangent, toa, opposite over adjacent, negative 24 over negative 10. So negative over negative is going to turn to positive. So positive 12/5. Cotangent would be positive 5/12. All right, let's look at the next one. In triangle PQR, angle P is a right angle, and the cosine of Q is 8/17. What are the sine of Q and the tangent of Q? So if you have no picture, just start with the picture. So we've got a right triangle. P is the right angle. PQR. So Q and R. All right. So it's giving us one of the ratios, cosine K, adjacent to Q is 8 and hypotenuse 17. So again, this is one where we're missing a side. So we have to use that Pythagorean theorem. A squared, 8 squared plus B squared, we'll let it be X, equals C squared. All right, then we can subtract that 64. We get X squared equals 225. So then X would be 15. All right, so why don't you take a minute to figure out what is the sine of Q and what is the tangent of Q. All right, so sine Q, sine so, opposite over hypotenuse. We're going to do 15 over 17. And we're not finding the angle, just leave it as a ratio. What is the tangent of Q? TOA, 15 over 8. All right, let's go to the next page. Okay, in triangle XYZ, angle Z is a right angle. X is 6 and Y is 4. What is the measure of angle Z? So a lot of this is review, just trying to be able to draw out that right triangle. X, Y, Z. Z is the right angle this time. X, Y, Z. I'm going to put X, Y, and Z. Now, when it gives us little x and little y like this, X, this is the side across from angle X. So the side across from angle X is 6. The side across from angle Y is 4. And we're trying to figure out what is the measure of angle Y. So we can go back to using our SOHCAHTOA. SOHCAHTOA. So we've got opposite and adjacent. OA, tangent of Y equals TOA 4 over 6. And so to find the angle, remember, if you're missing an angle, you can do the inverse tangent and get the measure of angle Y equals the inverse tangent of 4, 6, which ends up being 33.69 degrees. Okay. All right, number 5. We've done a little bit of this as well, but just a couple more, more practice with the word problems. It says an airplane climbs at an angle of 2.7 degrees from an altitude of 4,500 feet to an altitude of 5,600 feet. How far does the airplane climb as it travels? How far does the airplane travel as it climbs along, as measured along the horizontal? All right, so to start, the plane was already at 4,500 feet, and now it's climbing to 5,600 feet. So then we are focusing in on how did it get from here to here. So the plane was starting here, and then it traveled up to 5,600 feet. Okay, so it was traveling at an angle of elevation of 2.7 degrees. So what we're going to need to do is almost like think of a fresh triangle, because we're not actually going to use the 5600 number or the 4500 number. We're going to use a combination of the two. So can you guys imagine how far has this plane traveled vertically? So it had an altitude of 4,500 feet, and now it has 5,600 feet. So if we subtract those two, we get 1,100 feet. And we want to know how far does the airplane travel as it climbs along the horizontal distance there. So we want this angle down here, x. All right, so why don't you guys go ahead and set that up using sine, cosine, or tangent. So it should be tangent of your degree equals opposite over adjacent. We're going to move the x to the other side and then divide by the tangent of 2.7. And we get x equals 23,325.44 feet. So that's how much horizontal distance still needs to be covered, or will be covered in that time frame. All right, and the last one is very similar, but this one has an angle of depression, like the plane is descending into the airport. So if you start with the plane that's flying in and is coming to land at the airport, it says it's coming in to the airport at 3 degrees. So it's actually this top angle that's 3 degrees. The pilot is looking down to the airport at an angle of 3 degrees. The altitude is 5,000 feet. That's when the descent starts. And we want to know what is the straight line distance to the airport. So again, just that horizontal distance. So if we know the angle of depression, or this angle of descent, is 3 degrees, then the angle of elevation is also 3 degrees. So why don't you guys work on finding out what x is? You can pause the video if you need more time. All right, so it should be tangent of 3 degrees equals 5,000 over x, very similar to the problem we just had. So then it would be x equals 5,000 divided by the tangent of 3. So x is 95,405.68 feet. So your assignment for tomorrow is textbook assignment. It is 14.3, page 924, numbers 8 through 24 evens. Okay, so try to work on having that done for tomorrow.